Well, welcome everyone. Nice to see folks joining us here for our fourth episode in our live stream series, Tales from Beyond the Geofence. We're really excited about this, getting to learn how to provide you more content and connecting you with research that's focused on using drones and new technology to do some cool things. And really excited today to have some folks from the ocean cleanup and to some extent folks from our lab as well that have been working on using drones and AI to support efforts to try and clean debris from the ocean and understand more about how to detect it and how effective their techniques are, which is really exciting. And so I'm going to switch it up now, and we'll do some quick introductions. And I'm going to now pass that over to David Poling, who is a master's student in our lab and has been participating with this research project, over the last summer or so. So, Dave, take it away.
Hey everybody, I'm David Poling. I'm a master's student here at Duke Marine Lab. Um, I've kind of acted as the, primary representative from Duke with the ocean cleanup. And I've been fortunate enough to work with Robin and Juel here and a bunch of other people involved with the organization to do plastic research with drones. We go out and we do mapping where we try to use unmanned aircraft to identify plastic, to try to make counts and other sorts of measurements of where we see plastic pollution in the Great Pacific Garbage Patch. It's super rewarding work to do. It's a really good group. And I think that the technology has incredible potential for conservation here and elsewhere.
Awesome, thank you. I maybe we can pass it over to Robin now, and he can maybe give us a better idea of what the ocean cleanup actually is, and
Hmm.
and maybe how he got started on this journey.
Yeah. Hey, everyone. My name is Robin. I work for the Ocean Cleanup ever since 2018, and I'm part of the research team. And my mission in the Ocean Cleanup is to develop um, new methods to quantify plastic debris in the oceans as compared to classical methods or more conventional methods that involve trawling nets or physical sampling. Um, and so that's the journey I started on with the ocean cleanup in 2018. Um, we've explored the use of satellites, cameras, and drones, all to effectively map the Great Pacific Garbage Patch and also other oceans in the world. And along the line, we've developed this methodology that we're working on a publication for, um, and recently conducted a big piece of work that David and Jewel here were part of. But let me step back a little bit and tell you what the ocean cleanup really is about, because obviously that's not just research. Research is a small team in the ocean cleanup. It's about 7 people. But then there are two major teams working on the solutions to clean our oceans. And one of them is the oceans team, who have successfully deployed the latest system, over the course of the past year, extracting tons of plastic in the North Pacific Ocean. So that's the one team. And the other team is our rivers team, who are deploying interceptor technology all around the world, um, trying to catch plastic before it reaches the ocean, which is the other part of the equation, essentially. And so we're working on all fronts possible to prevent more ocean pollution from happening. Um, and our main mission is to develop this technology to rid the world's ocean of plastic. Um, so, in essence, what we do as the research team, it has a fundamental value, of course, gathering more insight into the plastic problem, but it also helps us as the ocean cleanup understanding more and better where to clean up, and if our cleanup efforts have any effect in the long run. So, with that, like to leave my introduction. Thanks.
That's great. Thank you so much for the introduction. I'm excited to learn more about the ocean cleanup. It seems like a really incredibly intricate and very demanding kind of job to try and do with the technology, and it's nice to see how these things are evolving through time. It's and the action part is just fantastic. Um, Jewel, do you want to jump in and just talk a little bit about your role and how you see the ocean cleanup?
Sure. My name is Juel Herbranson. I'm a drone pilot and project manager with a company called Spar Group, and I was hired as one of the drone pilots for the TOC. And my primary responsibilities were for the management of the flight automation and for flying the drones. And we had a really great experience. And basically, we were there to collect data and provide it to Robin for his research. And it was a really great experience. And one of the things we got tasked with was actually inspecting of all the data to make sure that it was of good quality and whatnot, and getting the lighting correct. So it was very challenging to do that out in the ocean. But it was a great experience, and it's good to meet all of you.
That's great. Thanks for being here. Um,
Yeah.
yeah, so I've one of the first when we first started our research group, we were really interested in marine debris, but not on the ocean. We were really focused on thinking about beaches and things like that. And at that point in time, there really hadn't been that a lot of work at sea thinking about how you could use drones as high resolution remote sensing systems to be able to find it. So it's really cool to see, even in such a short time. I mean, even in just the past 3 years, the changes, the new technology, how things are being applied has been pretty amazing to see. Um, I guess that one of the questions that I think people would really like to learn a little bit more about is kind of where does that drone sort of part fit into the whole process? And how does that link to the other remote sensing sort of systems and techniques that you guys are applying?
Right. Is that a question for me?
Yeah, sure. I think you probably,
Sure.
yeah.
Well, I can maybe share some material. Just hang on a little bit. I'll just open up the right material. Because there's definitely a bigger story around this, and why we're doing this. So I'd like to share that with you, if you don't mind. Let me
That would be
quickly
great.
open that up. All right. So and actually drawing this from another presentation I didn't think was necessary, but actually it comes in very handy. If you bear with me for a second. So yeah, I'm sharing my screen now, and I hope you can see it.
We can.
So in short, it all comes down to this. So here we are in the Great Pacific Garbage Patch, and it's sort of it's shown in the four figures to the right. Okay, here you see different size classes of plastics floating around in the ocean. Red colors indicate very high concentration, and the bluer color and smaller points indicate small concentrations of plastic debris. So you see that this outline here indicates sort of the roughest extent of the Great Pacific Garbage Patch. And by the way, you can see Hawaii here to the bottom left in these subfigures. Now, the point here really is that for each of these different classes of plastic, there are different types of methods that are most useful for classifying them. So microplastics and mesoplastics tend to go very well with so-called trolling nets. You can see one on the bottom here. And so it's relatively easy, so to speak. It's not easy work. It has to be done scientifically very well, but you can replicate it pretty well by using different types of sailing vessels or larger research ships and combine all the data together. What's a lot harder is to get a good grip on the quantity of megaplastics out there, and the reason for that is that megaplastics larger than 50 centimeters are more spread out, so they don't occur that much as you maybe expect them to. So roughly they are occurring once per square kilometer, which means that dragging a net through the ocean with a research ship, it won't do for getting a good sampling method on your megaplastic population, so to speak. So here's one thing that was done in 2016 when drones were still in infancy. We contracted this huge airplane to fly over these 2 strips over the GPGP, and thereby quantifying, megaplastic concentrations. So this was successful, but at the same time, it was very expensive. And it tells a story like there's a gap in methodologies for this larger plastic size class. And you might wonder what is so important about these megaplastics when they're not so frequent. And then we go to this little bar chart here on the left, which it shows the mass load in the GPGP in tons distributed over these different size classes. So while there are billions of microplastics, essentially, and mesoplastics, they only constitute, a limited amount of mass in the ocean. It's just because they are so small, even though there are with lots of them. And when we look at the megaplastics, they are by far the largest mass load in the GPGP. So that means these are nuggets of plastic, so to speak, that have a large risk of disintegrating into smaller plastics. So what happens if we leave these plastics here alone is over time this quantity of plastics, this mass load, will migrate into like these smaller size classes, and that's the core reason why we're after this larger size class. You can also see, by the way, the error bar here, which is still quite substantial. And that means that we are also eager to get a better confidence level on this quantity estimate for megaplastics. So I hope this tells a little background of why we're doing this. People might also wonder why not use satellites, for example. And then the question, or no, the answer is that as much as we'd also like satellites to be used, they prove to be very tricky to use over the open ocean. Not a lot of satellite providers regularly acquire satellite imagery over the open ocean. And even then, there's a resolution limitation. So even the highest resolution commercial imagery gets you to 15 centimeters per pixel. And that's unfortunately still not enough to really reliably detect these megaplastic items. Although they're larger than a pixel size, you need about 20 pixels for an object to become recognizable. So that really raises the bar for satellite measurements. And at present, that doesn't really work to detect these plastics, let alone the smaller size classes. And this is the key reason why we're turning to drones, for example, to get a better estimate of these size classes here. So I hope that answers your question.
Yeah, absolutely. It's really great to to kind of hear about how that kind of fits together and where you think drones are fitting in. Um, I'm always interested in that sort of the technical remote sensing part of of these kinds of projects as well. And I was wondering, um, do you guys use just the RGB imagery, or have you guys been experimenting with other multispectral type tools, and if those might be helpful? I mean, I know in like recycling centers, sometimes people use different wavelengths of light to sort things, and I wondered if that kind of technology might be helpful for you as you're starting to use these kind of flying sensors that could carry those kinds of payloads.
Yeah, a very good question, and I get it a lot. It's always tempting to throw in a bit of hyperspectral, multispectral there, like while it's out there, why not use it? And so I can also tell you that in 2018 we went to the GPGP. I'm sharing my screen again, so I hope you can see it all.
Yeah.
But then like this is me 5 years ago out in the GPGP myself. And what we did is we took a DJI M210 and we mounted 3 different slant range multispectral cameras on it, just to explore, what can multispectral bring to us. And well, by mounting these 3 sensors, you get a pretty good spread on different bands. And this was over our mission, or our system 1, also named Wilson. And it provided us this, this stack of layers with multispectral data. But as we came to realize, it's often difficult to synchronize all these different bands. And also most of these commercially available multispectral sensors have different, like slightly different perspectives and slightly different camera timings. So it's really a question of, or my answer to the question would be, I see great potential in it, but the reality is that optical RGB true color cameras are technologically more, more advanced, more developed, which gives them superior image resolution, exposure times, and also weight, which is important for, surveying large areas for plastic. As you remember, this 1 piece per square kilometer, these larger plastics, that becomes really important to be able to fly the drone long enough to scan a large portion of ocean surface. So yeah, we did this multispectral sort of a exploratory study. We could find quite some interesting effects there. One of the things that it could lead to is a better view on depth of particles. So what we also saw is that in the approaching the near infrared, you can see objects disappear underwater where they are still visible above the water, or they're still visible under the water in lower wavelengths. And by comparing these, we've also set out on a few fundamental studies to better understand those effects. But in reality, to map large portions of ocean surface with multispectral technology on drones, I personally think it's a little too early still, but we're definitely following all the developments very closely.
That's awesome. Yeah, it's pretty remarkable how quickly this technology has been advancing, and thinking about, what was available 10 years ago. When you're thinking about a research grade multispectral camera, it would have been, bigger than a bread box and probably cost $40,000, and now we can mount them on drones. So it's nice to see that maybe those things may, be helpful. um, and yeah, and I mean, always challenging over the surface of the ocean. That's always changing, sun glint, all of those problems just, really make it a pretty wicked problem, I think, for the quantitative remote sensing side of things. I want to pivot and ask you another question too, because I know, like, the drone technology, it's emerging and becoming very helpful, but you guys are also employing artificial intelligence and computer vision as a tool as well, which is another emerging and increasingly important tool for environmental scientists. And I wonder if you wouldn't mind commenting on the kind of AI approach that you're taking, and where that kind of fits into your overall program, and how it might help in the future.
Sure, of course. So yeah, why not share my screen again?
You bet.
I'm happy to. And so at the core of what we're doing at the moment is a object detection model that we developed the recent years, and it's based on YOLO version 5. It stands for you only look once. It's it's open source. It's PyTorch based, so it's a Python library, and you can run it on any decent gaming laptop or desktop computer pretty smoothly, I would say. And so we we take that at its core, and then we have a a workflow around it. So because obviously there's more to it than just the AI. There's also the position of the debris that you want to know. So what we do here, and this is getting a bit technical, but it's really sort of the flow charts describing what we're doing with the data. So on the top here, there is just the raw images. We ingest them in our loop, our programming loop, and the programming loop first, it runs the object detection in YOLO 5. And what it does then is it exports those bounding boxes that detect or have a look at later. The reason is that marine debris is a very tricky object to detect because they come in all sorts of shapes. And so we really have to sort of give it a second with the data to make sure you're seeing is really debris. Not being produced. We wrote another piece of software which takes all of the drone's positioning parameters, such as the GPS, latitude, longitude, but also the camera's orientation and also the drone's height above water. It puts them all together, and it then takes the original image and it projects it on the real world, and that gives every object projected from the image. And of course, this is estimated, but it works pretty well, well enough to distinguish size classes. So in this image here, I'm going to go back to it once more. You see the drone, passing through a patch of ocean and encountering plastic objects on its way. And so the size bubbles here also indicate the physical dimension of each object as we detect them and project them. And so what we do here, and you can see in the end, this big screen here, these are all different crops, as we call them. They're just object detection bounding boxes that we validate them on a big screen after passing through such a flight. And that immediately also acts as a quality assurance step. So you might be wondering, how does it look like, those bounding boxes? And so these are a few examples of curated detections that came from the drone. And so it displays the bounding box around what it thinks is plastic. As you can see, the confidence, which is indicated by this number here, it still varies quite a bit. As you can see also, the debris comes in different forms and shapes. So we've got this hard plastic category, but we have a lot of nets that come in different colors and shapes. We have loose pieces of rope, such as this. So it really varies between things that are very easy to point out and say this is plastic, and other things that are actually pretty difficult to distinguish, even from a human perspective. So that's really what the AI does, and just to show sort of how difficult it can be, this is, for example, an image taken from 80 meters up high during a different mission, I must say, that was in 2021. But so this is the full image, and so here in the bottom you can see this here object. I've just manually highlighted this bounding box just to zoom in, and this is actually 3-meter size ghost net. So you have a lot of information that you would never be able to get through by a human eye, because you would simply get tired and miss out on all these different object types. So yeah, I hope that answers your question about our AI approach a little bit.
Yeah, absolutely. It also kind of drives home that challenge. We've been using AI to do some animal detection work and thinking about how to measure animals and things in more efficient ways, and it often stems from this horrible experience that people have literally counting thousands and thousands of animals on the screen. We find that normally when students work with us, they'll work on that kind of project once, and then they'll quickly learn how to code in Python so that they never have to do it again, because it is, like you said, so challenging, and I think people end up missing things. They get tired. It just becomes a very hard to manage process. And so, yeah, I guess that's the other question. I mean, you guys are generating all this imagery. Are you the person who has to go through and do all that labeling and everything, or do you have a team of folks who are helping you with that? Because it's a big task.
Sure. Yeah, it's a good question. Well, so to be honest, the algorithm does a really big part of the work already, because it already pre-annotates everything. It has a first pass over it, and for these aerial missions, I typically can go through them myself within 1 or 2 days work. That's not to say I always do it by myself. So yes, we have volunteers within the organization. We have work students, interns working on this project and helping us. And every now and then we also launch crowdsourcing events where people can do the labeling crowdsourced. On the other side of the equation, we're also working to improve the algorithm even more. Um, Not necessarily making it 100% successful, but really driving down the order of magnitude of false positives by 1 or 2. Um, and yeah, it's as you say, it can be a lot of work. One other project we're doing is involving cameras on ships, and that's where we really build a large amount of data. We leave the cameras running for days on end, and in the end, we have terabytes of images, raw imagery.
Mm.
So then it quickly builds up to tens of thousands of these anomalies to validate, and that's where definitely we make use of some more help.
Yeah, I bet that sounds like a gargantuan task. And so, when you're thinking about, I know, so when we're labeling things, we're working with a species, so we can define the individual animal as a particular species, maybe even an age class, it's a pup or an adult or a calf, that kind of thing. When you guys are going through and labeling that imagery, is it all just one class? Or does your model start to be able to kind of identify net versus large plastic versus those kinds of things?
Yeah, great question. Also, at the moment, the model just does a single class. It's starting to get better at different classes, so we're running some experiments in the background where it's doing that. And the key challenge there is to have a well-balanced data set to train with. And truth be told is that we are still building the training data set for some of these categories, since they're important, but they're still a little too rare to to have enough examples of them. So so that's the reason the AI currently does one class. However, in the second step, when when you have those validations to do, it's very easy to attribute classes to them. So um, I'll share my screen once more. This is what we did for the missions last year in 2021, where we did those 22 flights using a fixed wing drone, and we detected a little under 2,000 different plastic types or plastic items, um, and by simple manual classification of these 2,000, it really goes faster than you think. Uh, we obtain this distribution. So we can already, what I'm saying is we can already extract that information from the program's current output. But of course, we're looking for ways to accelerate that process.
Awesome. That's great. Yeah, thank you so much for unpacking some of that for us. I think people have are generating a greater appreciation for how these tools can help you know, and that they may be able to reduce some of the resource limitations that people face, right, when they're trying to do these kinds of things. Whether you're trying to estimate the amount of debris in the ocean, or the number of seals in a colony, or the number of, you know, shorebirds in a particular location. So it's really cool to see how that is now being applied in this particular sense. I wonder if it. Oh, go ahead, please.
Yeah, sorry. Just to add to that, I would just like to raise the point that, you know, often when it's about AI, people are about building the perfect algorithm or building something that really beats all the other AIs. What I've come to learn during this 5 years of this project is, at some point you got to roll with something. So it's better to have something that works 80% but is consistent and leads to results you can compare between different missions, than to have sort of the ideal AI. So maybe that inspires people to just, you know, start generating results and using them for further science, because in the end it's a tool, and it's, you know, it's just something that, as you also say, it accelerates the process, and it helps people doing their research.
Yeah, yeah, that's a great point. Absolutely, I feel like there's a lot of you know, waiting until you have the perfect thing is just not an option, I think, a lot of the time. Um, and so, yeah, I think it's really great to see that, you know, and this is where we make progress, right? We're actually trying new things, and if we didn't do that, right, like you didn't apply it and iterate it, then you wouldn't really get very far. I wonder if there's an opportunity now to kind of switch to more of the operational side of things, and kind of maybe just think a little bit more about how that data gets collected. I know, you know, that operating from ships is always challenging. There's lots of really interesting nuances about that. So I'm wondering if it might be an opportunity now to pass it over to David and Juel and talk a little bit about the experience that they had, and talk a little bit about maybe some of the challenges, and maybe just, you know, some insights into what it was like to spend some of their summers out there on the in the center of the North Pacific, flying drones.
Thanks, Dave, and thank you, Robin, for coming in and giving us all this information. It's super useful, and I hope the audience is enjoying as well. I am watching the chat, and we have the Oceans Unmanned guys here watching us today. Matt, Todd, and Brian, I'm not sure which one of y'all are here, but they've been a critical component of bringing everybody in this room together. So thank you guys for stopping by and everything that you do. I guess I'll open and then pass it off to Juel. Offshore drone operations are probably the most fun, but the most intense thing I've ever done in my entire life. It's kind of like playing Top Gun. I kind of get to play Maverick, flying my aircraft off the ship, and then the weather and dealing with all those other things, and it's really interesting. But it does come with some super, super unique challenges, partially because, for example, the ocean cleanup, Robin was describing the oceans team. They have a group that is out on the water, actually kind of driving around and collecting plastic. Robin, feel free to add whatever you want to this, with the explanation of, they have something called System 002. I might actually have a slide for you, Dave, in a moment. Actually, yeah, Dave, if you wouldn't mind putting my screen share up,
Yeah,
thank you.
We've got you there.
So one of the things that the Ocean Cleanup does is, with their oceans team, their mission is to go out into the Great Pacific Garbage Patch and actually collect plastics. So for one of the missions that I was on, I was working with System 002, they nickname it Jenny. And basically what they have is they have two large ships, they're anchor hauling ships. They're meant for dragging oil and gas platforms around. They're the perfect kind of vessel to then go out into the open water and drag a 1.8 kilometer long net around. So what happens is that these ships, there are models where we think the plastic are, there's models of the locations where we think the plastic are. The ships will then drive through those locations. And what happens is that you have this large system here where, as you're sailing through an area that has a lot of plastic debris, the debris will all kind of be coddled in towards the back where they have something called the extraction zone that sits in the very back. So all the plastic, so you're not catching plastic necessarily all along this device, but it's being guided in by these wings on the side into this extraction zone. The plastic can then be, the plastic then accumulates in said extraction zone, and then it can be pulled out of the water, dumped, sorted. But about our first operation, here's another picture of it from the back. One of the operations I was on was we were operating off of these ships. And what you learn is when you have an operation like this, where you have people constantly maintaining the nets and checking the tensions, and there's 100 different roles that go into making something like this work as you're out at sea. And the only support you have is the people and materials you have with you. So it's very busy and it's very exciting. So I'd say the first challenge I think you encounter, or one of the main ones, is coordinating with all of the other people on the ship. And this is also one of the most fun parts about it, because I think what you learn is that there's very few people that are not only on the water like this, but are working on an operation like this who don't want to be there. So you get all sorts of different people who are all very passionate and all have a lot of energy for what's happening, who are all trying to coordinate. So, for example, on one of these ships, you'll have cranes and things moving around, and you'll have course corrections. What you have to do is when you're doing flight planning, you have to make sure you're constantly in communication with the bridge about where the ship might be going. Most drone flight plans are automatic, so you put an aircraft in the air and it will automatically fly a grid. You can take over at any time, but you also want to make sure that when you build that flight plan, the ship's not going in the opposite direction and you're not flying this way. So there's all sorts of interesting coordination and communication. Honestly, it's a fantastic team building exercise. Constantly, you're on a radio and you're talking to the bridge the whole time, and it's really fun, actually. I'd say the other big thing is kind of just getting used to life at sea. The longest that I've been out was with this exact same system. We were out for 6 weeks, and it's actually funny because I actually find these longer trips easier than the shorter trips. I think on a 2 or 3 week trip, by the time you get settled in, by the time you're not really nauseous, you're not swinging around too much anymore, you're already back on land. So it's this kind of interesting going out for these longer trips, where you do have to get used to the routine of things, and you kind of have to find your rhythm working in a more confined space. Which is funny because you'd think it wouldn't feel that way as you're out in the middle of the ocean. And I think when you go out and you stand on the deck of a ship and you look out over the water, it's incredible. I mean, it's serenity, but your day-to-day life is confined effectively within a metal box. So it's kind of getting used to kind of finding your own space. On every mission I've been on, you've needed some sort of, whether or not it's a drone mission or it's some other kind of science, you need room to lay out all your gear and do maintenance and have computers out for data management. So it's really about, I'd say really the biggest component is about kind of finding your rhythm, living at sea, and then being able to coordinate and work with everybody around you. I've had the chance to work with some people who are difficult, who do not do well with the somewhat claustrophobic environment, and there's always challenges there. And I've had other situations where I've been able to work with guys like Juel, where you get on the boat and you just get right to it and you make the best of what you have. On the trip that we went on together, we were staying in these tiny little single man cabins at the bottom of a bow, about an 150-foot long ship, which sounds big if you go on day-long fishing trips, but with 25 other guys in the middle of the ocean, that's a small boat. And we would hang out in the very bottom bow in these tiny little cabins we'd have, and we'd watch movies and we'd hang out with people, and you kind of use the space to kind of the best of its potential. So I'd say there's some really interesting aspects of working offshore, and that's not even directly addressing the use of drones in those situations. I don't know what your thoughts on any of that are, Juel.
Yeah, I have to concur. The biggest challenge for me was just getting, of course, adjusted to sea life, which is something that I had never done before. I'd done some ocean fishing for 6 hours, right? So I found out very quickly that I can actually develop sea legs and I don't get seasick. So that was 2 big pluses. And David and I immediately had a great working relationship and a good friendship. So that made everything just from the start much, much easier. The course, as far as operating the drones go, the biggest immediate problem you come up against is that you get out to sea and you realize, you brought the spare parts you have with you, and that's it. And any problems and solutions that you need are the ones you packed, right? Because there's really not even any internet connection. So most of the problems we ran into were kind of solved kind of on the back of the napkin, so to speak. And it turned out great. I think we prepared really well, so we had options to turn to. And it's the kind of thing too where you get out there and you're 30 feet above the water and everything's going 15 feet every direction, and you realize, oh, our takeoff point is 30 feet above the water. We have to recalculate all of our overlaps and everything like that. So we just kind of made a project out of it, and by the end, it turned out to be awesome. It was an incredible experience, and I think that we got everything we set out to get. But that was the main thing, was adjusting to sea life. And David's right about being out there longer than shorter is great, because you do get into kind of a rhythm. The first couple of days are a shock for a lot of people, and there's people who were professional boat managers that we were with who took 3 days to adjust, right? So it was pretty eye-opening from that regard. Now, as far as actually operating drones, that's actually was a big challenge, and I think it's a big challenge pretty much for anyone in the industry to adapt to this, because I do a lot of automated mapping and a lot of automated flight, and my preference, of course, is always to have the drone land and take off on its own, right? That's the ideal situation because it's the safest and you can plan. But in a situation like the being out in the middle of the Pacific like that, it really quickly became obvious to us that we had to hand launch and hand catch the drones, and that presented a big risk right there. So you're trying to avert one risk, and now your fingers are going up into 25-inch props. So we had to work around that, and we got a really good workflow out of it. And so our entire method became very quickly about safety and workflow, and trying to repeat what we knew worked. And so in the very first couple of days, it was a lot about trying to figure out, the experimentation, get out of the way now. And then once we had solutions that we knew worked, we'd stick with them and move forward and try to get as much data as possible. A little bit of experimentation, we tried to send Robin some stuff that he had some variation in altitudes and things like that. But even then, flying too low to the ocean, all these, hazards popped up. So it was a very good educational experience and life-changing from a social standpoint. So I'm very grateful to have been able to go through it.
Well, that's
Thanks,
awesome.
Juel.
Yeah, really, really amazing insights. I love to hear about that life at sea, and I think that's a pretty important thing for people to be thinking about. Um, I was gonna say that it might be good for viewers to learn a little bit more about the actual systems that you're using. So in this summer, what were the things that we were the platforms that you're using? Can you give people just a sort of an idea of that? Fixed wing, multi-rotor, and maybe some of the things that you use that were a little more advanced. I know you guys were using some tethers as well.
So, yeah, Juel and I together were primarily using multi-rotors. For those who are familiar with DJI, we were using a Mavic 2, and then we were using a Matrice 210. And both of these drones were carrying RGB cameras pretty much the whole time, which actually, as Robin's kind of explained, works well and makes a lot of sense for the kinds of plastic research right now. One of the really cool things we got to work with, as Dave mentioned, was a tethered system. I've got a slide in here somewhere on that. So this is kind of a shot. This is when we were still really close to port. We were sailing out of San Diego, so you can see the water's not quite as blue as it could be yet. But what a tether system is it effectively where you have a box that sits on the ground and connects to the drone. And what's happening is that this cable right here is feeding power to the drone. And the drone, if you can see right there, it has a little backpack that has a cooling fan to keep the battery cool, because it's constantly charging the entire flight. So what you get is these tethers are, I think the one we were working with the Mavic, which is what we primarily used, was about 60 meters. You have about 180 feet of line. And what that means is that within whatever kind of radius you can fly in, you have infinite power. I think our longest single flight from takeoff to landing was about 140 minutes with a small multi-rotor, which in that moment, coming down from that flight and landing and looking at my watch was the most insane thing ever. I mean, these are aircraft that if you leave kind of some extra battery life for emergencies, you do kind of a safe recovery, you're in the air for 15 minutes, maybe 20. So that was really cool. So the other thing that these systems have is they not only have a power cable that feeds to the drone, it's very light, so the drone can lift away and carry the power cable around as it needs to. And the fact that it's constantly getting new energy too means it can run a little aggressively and have no issues because it's not going to drain its battery fast, obviously. Um, as these also have a reel system attached. The tether is on an automatic reel, so that as you fly away, if it was just a loose rope, if you're flying around a ship that has antennae and all these other things sticking up, maybe even cranes, you don't want this effectively 180-foot long fishing line just kind of whisking around in the wind, getting tangled and everything. So what these systems have is usually some sort of self tensioner. So as the drone is taking off into the air, the line is staying taut. It's not waving around. And these tether systems proved pretty reliable. We flew, I think, about 18 hours over 8 days on this mission, and I think most of those hours were on the tether, at least for the mission type that they were being used for. And it was super cool. One thing that we did come across is these tethers. Very impressed overall by the technology, but they were not developed for offshore operations. So as Juel was describing, you have massive feet of movement in any direction as the ship's bowing around. So what that means is the the tether is on the boat, the drone is in the air, you constantly have huge amounts of tensioning between the two. So what did happen is we did have some tangling issues where within the tether, there was just so much strain on the actual reel mechanism that it did sometimes get tangled internally. And we actually ended up having a really clever solution to this. I've got this in here somewhere. Where what we realized is that the issue we were having was the fact that the tether, we weren't using too much line, but the fact that the motor that operated the reel did not like constantly tugging as the boat was constantly pulling the drone away versus sitting statically on land in a field. So what we realized is that if the drone sits at a relative position next to the ship, even if the boat is rocking, the two between each other are not actually moving that much. So what we were able to do is we were able to turn off the automatic tether, the automatic reel, so that the line, as we said earlier, just kind of is allowed to flap around. But what we realized is that this can actually be advantageous, as if the ship and the drone are rocking next to each other, it gives it a lot more play. To avoid the tangling issue, what we ended up doing is we actually ended up taking Velcro straps like you see here, and we were strapping them to the railing and strapping to the antenna on the boat to guide the line out and away so that you could have that loose line so there wasn't tension as the boat was rocking, but you were also avoiding entangling issues. So what we ended up doing is Juel, for the most part, ended up manually feeding the line out, and we used the tensioner just to reel it back in as we needed to. I think that was one of the more interesting technical challenges that we encountered.
Yeah, it was almost like a fly fishing cast in the end. You kind of get the right amount of tension out. The whole thing acts like kind of a shock system.
One thing that I think could be good to touch on, Juel, is a little bit about imagery. I think any camera and drone people who have ever worked on water will know that glare is a massive issue. And kind of as Robin touched on earlier, it's hard to discern some of these smaller pieces of plastic. And one of the biggest issues you encounter there is that a lot of the small fragments you'll encounter are white, or at least a pure white in the sheen of the ocean. And breakers, swells, white caps, as the water is breaking, are also white. So you get issues where the plastic kind of blends in with the water very well. The other almost biggest issue you encounter, though, is not necessarily any individual white cap or swell, but is the overall glare coming from the water. Dave, if you could share my screen again.
You bet.
This is an example shot. This was our very first, after we actually got to the garbage patch, we ended up traveling for a handful of days out into the ocean to get there. Once we actually got into the garbage patch, this was an example photo from our very first plastic observation flight. This is simply a shot of the drone from about 100 feet in the air looking down on the water. As you can see, this is pretty much unusable data. There could be 100 pieces of plastic in that picture. I could not tell you where they are. So how you counter that, though, is simply with your camera settings and how you position your drone. To kind of keep good data quality, you can kick your camera out to kind of counter the glare to a degree, but you don't want to do that a ton. So the general strategy ends up being that, as much as that, it ends up being actually changing the settings in the camera. This photo was a result of the default camera settings. So we just let it do its thing. Sometimes this works, sometimes it doesn't. We ended up changing a couple camera settings and slightly changing how we position the drone, and it can make an amazing difference. So in one day, we went from this photo on our very first flight to this photo. These were taken at a similar solar angle, similar weather conditions. It doesn't even look like they're from the same planet. And you can see down on the bottom left, we actually have this piece right here, which is a piece of plastic. And you can see some fragments also around the area. So that's one of the biggest things we learned, is how to kind of play with the camera, how to play with how you angle the drone relative to the water, and how you play with the camera settings, because understanding those things is completely imperative to getting good data while you're working on the water.
Yeah, and that's one of the things I was going to say as well. One of the challenges we had is that I think the starter for the engine failed, and we ended up getting delayed like 4 days, and so our schedule got compressed, and that kind of forced us to fly in moments where the sun wasn't ideal for us. And so one of the big challenges there was having to go, okay, we're going to have glare. It's going to happen. So it's going to change right in this critical moment of these few hours. So we ended up getting experimenting pretty deeply, actually, with how to get the camera to fix to the cardinal directions against the sun, and what angles were acceptable without causing too much pixel distortion on the surface. And we ended up coming up with some pretty good solutions. And the platforms that we were using for the flight automation, we learned in the advanced modes are actually able to take into account cardinal direction and position cameras away from glare and things like that. We were able to use like the big magnetic compass on top of the boat, which came in handy, which was kind of a cool experience, actually.
Oh, that's amazing. Yeah, it's really cool to see how you have to kind of improvise and innovate when you're out there in the ocean. Like you said, once you've gone, it's everything you have is what you have, and that's it. And so being able to think quickly in different ways is key for success. We've got about 5 minutes left, and I was kind of wondering if we might have the opportunity now to switch and maybe pivot back to Robin, and maybe he could lead us in a little bit of an exploration of what we can do to try and help. As people who are interested in using drones, people who are interested in applying new technology to these wicked problems. It'd be great to hear from your perspective how we as enthusiasts, or maybe early career researchers, people that are interested in this, how can we help? And maybe that's specifically with the ocean cleanup, or maybe that's through other ways. But it'd be cool to hear from you and think about, help us think about that.
Sure. So my initial response to this question really is go out there yourself, be a citizen scientist. I think that's really what we're striving for, is get more eyes on the ground. And if this is a community that have experience flying drones and the licensing to do so, or are generally interested in collecting imagery, even by camera or anything, I mean, go to your nearest river, collect data for us. We also have 2 survey apps, and it's an app that's designed for river surveys. You can go and stand on a bridge. You can count plastic. This is no imagery or AI based approach, but it's a little more accessible for whoever doesn't have the tools necessarily to fly drones or run AIs. And then there's also an ocean survey app for anybody who regularly goes out on boats, or does so every now and then. Also counting plastics and be a visual observer. That also helps us build our heat maps of where plastics occur, around the world and where a cleanup strategy might be most effective. So I'd really like to highlight these two. And then on the more technical AI front, keep an eye on us, as we might call on our community to do more labeling of data, for example, in the future. And as I said, we will try to publish this methodology of processing the imagery. And if we do that and we're successful in it, that allows others to also collect imagery, run the analysis for themselves, and share data with the public and with the community. So there are a couple of ways there. I'm sure there's one of each liking in it.
That's actually fantastic. It's really nice to have like concrete ways that people can actually participate in, and we'll definitely include the links to your apps and the ocean cleanup in the description for the video when we put it up online, so that people will be able to directly access those things. Yeah, it would be really wonderful to see if we can generate a little bit more help in that space to push things along. And I think probably that's probably a good place for us to take a break. We're just about at an hour now, and I think this has been a really fantastic conversation. I want to thank Robin and Juel for joining us, providing us this really great window on the world that they're dealing with right now, and providing us, I think, some inspiration on how we can think about applying new technologies to these situations. And also thanks to David for representing our lab and for representing the Oceans Unmanned folks on the project. I think it was a great experience. From my perspective, I always worry, I have, as an advisor of students, you send people off, and sending someone off into the middle of the ocean to fly drones over, the garbage patch is not something that happens every day. So I want to commend David on his excellent work and his willingness to get us all connected on this for the live stream. So yeah, thank you very much. We really appreciate this, and I'm hoping maybe sometime in the future we can circle back and get you guys back on when new things start to drop out. It sounds like there's a lot of cool stuff in the pipeline. Does anyone have any last words they want to say before we sign off?
I feel like I just owe one more thank you. I owe Dave as much as the thank you I think as you owe me for ultimately getting me started in this world, so that I could now kind of loop these guys back in. And thank you to Chelsea, who's behind the scenes right now. You can't see her, but she's helped organize everything. She's our social media person, and has gotten the live stream actually set up. So appreciate the whole team here and the whole team at the Ocean Cleanup and at Oceans Unmanned.
And just to say, it's great for you guys to have me. It's been a pleasure.
Yeah, I concur. Thanks for having me. It's been a pleasure, and also a special word of thanks, of course, to Oceans Unmanned, who have initially brought this piece of work together and brought me in touch with David and Juel. So big word of thanks to them and our collaboration there. So yeah, thanks all.
Great. Thank you so much. All right, folks. Well, that's it for now. We had another great live session. Thank you for joining us, and looking forward to seeing you in the future. And remember, always fly safe.